All right, so this is a look at the new subdivision level 0 option in MeshFusion. It's a very simple thing on the surface, simply the ability to use subdivision level 0 on any MeshFusion source mesh. But it's quite powerful, really extends the usability of MeshFusion, and it has some subtleties in its application and workflow that we'll need to take a look at. Up until now, certain mesh topologies required MeshFusion to use at least or 2 levels of subdivision. Actually, sometimes it would be 1 level of subdivision, but in some cases it would require MeshFusion to use 2 levels of subdivision on a source mesh. And if your source mesh was already pretty dense like this is, that was a problem. Those topological features include things like triangles, which this mesh has a couple. N-gons has one of those back here, and other mesh topologies like vertices that have 3 or 5 edges converging on them, like we see at the base of these little blocks here. So as I say, up until now, if you would try to use a mesh like this as a Fusion source mesh, it would get subdivided twice, which is really something way too dense for most practical uses and really undesirable. So now, and with a mesh like this, what would happen previously is if you tried to change its subdivision level to something less than 2, MeshFusion internally would just override that and force those 2 levels of subdivision. But now we are free to knock that all the way down to 0. As usual with MeshFusion, don't be misled by these triangles here. Let me turn up this wireframe opacity a bit. That's just the way MODO draws procedural meshes of the sort that MeshFusion creates. Those triangles are actually there once we output the Fusion mesh. These quads actually will be quads. So yes, the MeshFusion model in this case, MeshFusion mesh, if we hide the source mesh, is structurally identical to the source mesh, topologically identical. But you will notice that some things don't look quite right, like those little teeth that we had here. Clearly the shading is not correct. Now that's because MeshFusion produces a normal map. It has to. We'll look at that in detail once we start doing some actual Fusion modeling with this mesh. But it's just the only way that MeshFusion can give you good, clean shading on your models is to produce a normal map. And since that is in play, it means that the usual way that MODO shades sharp edges just automatically isn't allowed to work. The normal map takes over and you get this kind of undesirable shading effect. But we can deal with that once we output the mesh. But before we do that, if you look closely, you'll notice that there's more to it than that. The geometry actually does not match. And that's because, again, since everything is converted to Catmull-Clark by MeshFusion, the nature of the geometry does change even with subdivision level 0. But for the purposes of a model like this, we want to override that and use a MeshFusion option that has long been there, but we really haven't had that many uses for until subdivision 0 came along, which is this cage vertices. So you see the discrepancy there between the actual geometry and the source mesh. If I turn on cage vertices, now at least the meshes match. The shading is still wrong, but we've got the mesh matching, and that's what we would want in a case like this. Now, it's important to note that any of these topological features that previously triggered the automatic 2 levels of subdivision are still incompatible with MeshFusion, only in the sense that you can't have Fusion seams and the strips they generate pass through any of those areas. But in many cases, as in this mesh, those areas are small and isolated, and quite likely in places where you weren't planning on doing any fusion modeling in any case. But you will need to be aware of them and avoid them. And we have a little tool here, a little addition to the UI that will help you identify and avoid those areas. It's this Hide Incompatible Polys checkbox. And if we turn that on, it simply hides any polygons that you should avoid. That includes, in this case, triangles and some adjacent quads, a lot of the polygons around those teeth, and this n-gon in the back here. And I'll point out right away that you want to make sure to only use this as kind of a diagnostic tool. If you were to output the mesh at this point, those polygons would actually be excluded. You don't really want to do that. This is just to kind of help you identify them. So we'll turn that back off. Now you see, even when I turn that off, the n-gon is still excluded. And that's because while these other topological features, including triangles, are all handled completely automatically, currently we're not handling n-gons automatically. So you will need to, we hope to, and we will plan on adding that automated feature soon. But in the meantime, you will need to do something about any n-gons in your model if you're going to use subdivision level 0. The most foolproof method of dealing with n-gons is to simply triple them, as it's called. In some cases, you'll be able to quadruple them. The choices that you make here depend a lot on whether the polygon is planar or not. If it's very non-planar, tripling is usually the safest bet because it will obviously create planar triangles, since they're always planar. In this case, quadruple will work fine. And so I have essentially repaired that n-gon as far as MeshFusion is concerned, and we are now ready to model. So let's bring in a couple of trims that I have. Oops, that's not it. Pre-prepared here. So here we have a little array of cylinders. I'm going to select that and select our main mesh here. Go over to Fusion and do a regular old subtraction. And that all works just fine, because of course it's not anywhere near any of those problematic areas. Now, a slightly more interesting case is this sphere here, because the sphere itself has triangles. And naturally, you see them at this pole, and they're present at the other pole. And again, this illustrates that point that it's only seams and strips that must avoid these areas. That other pole here, you're going to see once I apply the subtraction, is nowhere near the seam and the strips that will be generated by doing this subtraction. Let's hide the source meshes here so we can see things more clearly. So everything is fine, except, of course, the default 2 levels of subdivision have been applied to this sphere, and it's another case where we really don't need those high levels of subdivision, so we can go ahead and turn this down to 0 as well. And there are those triangles, and they're not creating any sort of problem because they are not involved in the actual intersection. So all that's left in our desire to get a fusion model that is very faithful to the original source mesh, all that's left is dealing with this issue of normals. Currently, there's no way for MeshFusion, the type of procedural mesh that MeshFusion creates, to generate normals for only some vertices and not others during live fusion, but we can certainly take care of it once we output the mesh. So let's go ahead and do that. Select the fusion item here, dupe and convert to mesh. We've got it set to airtight final with parts in this case. And create the mesh. I'm going to turn off some of these shading groups that Fusion generated. And there's our mesh, and all looks pretty good when you look at it with the wireframe, but that's kind of hiding these shading and normal anomalies, so I'm going to go ahead and turn wireframe off. And there we see the problem, especially in these areas here. Now, I'll note that much of this mesh looks pretty good because it was modeled in such a way that there are edge loops, so it really is a smooth surface, and that's what MeshFusion does really well when it generates normals. It generates absolutely perfect normals for any smooth surfaces. And just to make sure we understand this and be clear on why this manipulation of normals is necessary, let's look at a critical area up here where MeshFusion is in play and creating a rather chaotic mesh. Of course, as always, a good way to reveal the problems with such an area is to turn on reflection mode. And you can see it all looks quite nice. The normals there are ideal, and that's because MeshFusion has generated this normal map. And if we were to throw away that normal map, you can see that we have serious problems with shading around those trims. So it's absolutely essential that we generate that normal map and that we continue to use it once we output the mesh. But it's that very normal map that is causing these areas to be shaded incorrectly. As we'll see here once I bring the normal map back. With the normals back in place, these areas aren't what we want. So let's go back to default mode here. So now with an output mesh, a regular mesh, we are free to disable normals, clear the normal map in those areas where we don't want it applied. So for example, just go here and select some polygons. And it's a good idea to have, if you're going to disable normals for some polygons, it's a good idea to have that boundary where the normal map is cleared, be on an area that's does not contain a lot of complex curvature. So areas like this will be fine. And now when I clear the normal map, it's only going to clear the normals from those selected vertices associated with those selected polygons. And there we have our shading back to where we would like it to be on those parts of the model. So now this is essentially identical to the original source mesh with the addition of our Fusion features, our Fusion modeling. And this is something that just was not possible in the past. And of course, once you clear the normals on any part of the model, you're free to use all of MODO's normal tools, the new edge hardened tools, that sort of thing. In this case, I'd be perfectly happy just with normal shading and probably use edge rounding on the material level to get the results I want when I render this thing. But at the same time, we're getting those perfect normals generated by MeshFusion where they are needed. And again, I'm quite happy with many areas of this mesh where the mesh topology itself is such that the MeshFusion normals give me just the results I would want as far as the edge quality and shading of those areas. It's really only the areas where the polygon mesh was very kind of crude and strictly a polygon mesh, like those teeth at the ends of the arms and even the cylinders that lead up to those teeth. Those areas needed to have the normal map removed, the rest of it. In this case, it's just fine. That'll vary, obviously, from model to model, but ultimately, I think in just about any case, you should be able to get the kinds of results with this kind of mesh that were just not accessible before this feature with MeshFusion. All right, that's it for this one. Thanks.